In the vast expanse of our planet's oceans, a remarkable phenomenon unfolds. Tropical cyclones, nature's whirling giants, are born. These massive storm systems are known by different names around the world. In the Atlantic and Northeast Pacific, we call them hurricanes. In the Northwest Pacific, they're typhoons. And in the South Pacific and Indian Ocean, they're simply cyclones. But regardless of their name, these storms share a common trait. They are among the most powerful and awe-inspiring forces of nature. Tropical cyclones can span hundreds of miles in diameter. They can unleash winds of over 155 miles per hour, and they can dump torrential rains that lead to catastrophic flooding. Join me on this journey as we unveil the power of tropical cyclones. The birth of a tropical cyclone is a complex process. It requires a specific set of conditions to align. First and foremost, these storms need warm ocean waters. The surface temperature of the water must be at least 26.5 degrees Celsius, or 80 degrees Fahrenheit, to a depth of about 50 meters. This warm water acts as the fuel for the storm, but warm water alone is not enough. The atmosphere must also be unstable enough to allow the warm, moist air to rise rapidly. As this air rises, it cools and condenses, forming clouds and releasing heat. This heat further warms the air, causing it to rise even more rapidly. This creates a cycle of rising air that forms the foundation of the storm. Another crucial factor is the Coriolis effect. This force, caused by the Earth's rotation, helps give the storm its characteristic spin. In the northern hemisphere, cyclones spin counterclockwise. In the southern hemisphere, they spin clockwise. If all these conditions are met, a tropical disturbance can evolve into a full-fledged tropical cyclone. When a tropical cyclone makes landfall, coastal regions bear the brunt of its fury. The impact can be devastating and long-lasting. The most immediate threat comes from storm surge. This is a wall of water pushed inland by the cyclone's winds. Storm surge can reach heights of 20 feet or more. It can inundate coastal areas, causing severe flooding and erosion. The high winds of a cyclone pose another significant threat. These winds can topple trees, damage buildings, and send debris flying through the air. In some cases, entire communities can be leveled by the force of these winds. Heavy rainfall is another hallmark of tropical cyclones. These storms can dump enormous amounts of rain in a short period. This can lead to widespread flooding, landslides, and mudslides. The long-term effects of cyclones on coastal regions can be profound. Yet despite these challenges, many coastal communities have learned to adapt and build resilience in the face of these recurring threats. The strength of a tropical cyclone is a testament to the incredible power of nature. At the heart of this power is the process of heat transfer from the warm ocean to the atmosphere. As warm, moist air rises, it creates areas of low pressure. Surrounding air rushes in, creating the cyclone's winds. Wind speed is a primary measure of a cyclone's strength. In powerful storms, winds can exceed 155 miles per hour. These are classified as Category 5 hurricanes. Wind speed, rainfall, and size determine a cyclone's strength and impact. Section 5. Anatomy of a cyclone. The eye of the storm. The structure of a tropical cyclone is a marvel of nature's engineering. At the center of this swirling mass of clouds and wind lies one of the most fascinating features, the eye. The eye of a cyclone is a region of calm weather at the storm's center. It's surrounded by the eye wall, where the most severe weather occurs. The eye can range in size from just a few miles to over 100 miles in diameter. Inside the eye, winds are light and skies are often clear. The air pressure here is at its lowest. This stark contrast to the surrounding chaos has led to many stories of people experiencing eerie calm in the midst of a raging storm. Surrounding the eye is the eye wall. This is a ring of towering thunderstorms where the most extreme weather occurs. The eye wall contains the highest winds and heaviest rainfall. The entire structure of the cyclone rotates around the central eye, creating the characteristic spiral pattern we see in satellite images. Section 6. Fascinating facts about tropical cyclones. Tropical cyclones are not just powerful forces of nature, they're also sources of fascinating scientific facts. For instance, did you know that cyclones can produce sound waves that travel into space? NASA satellites have detected these infrasound waves, which are below the range of human hearing. These waves can provide valuable data about the storm's intensity. Another intriguing fact is that cyclones can trigger earthquakes. The low pressure at the center of a cyclone can cause the Earth's crust to bulge slightly. This, combined with the weight of the storm surge, can trigger small tremors. Cyclones also play a role in global heat distribution. They help transfer heat from the tropics to higher latitudes. This process is crucial for maintaining the Earth's energy balance. Without cyclones, the tropics would become much hotter, while higher latitudes would be colder. Section 7. Cyclones and climate, a complex relationship. The relationship between tropical cyclones and climate is complex and multifaceted. On one hand, cyclones are influenced by climate conditions. Warmer ocean temperatures, for instance, can fuel more intense storms. On the other hand, cyclones themselves play a role in shaping our climate. They help redistribute heat and moisture around the globe. In recent years, the impact of climate change on tropical cyclones has become a topic of intense scientific study. While the total number of cyclones may not increase, many scientists predict that we may see more intense storms in the future. This is due to warmer ocean temperatures providing more energy for storm development. Cyclones also play a role in the carbon cycle. They can cause significant disruption to coastal ecosystems, including mangrove forests and seagrass beds. These ecosystems are important carbon sinks. When damaged by cyclones, they release stored carbon back into the atmosphere. Section 8. Tracking and predicting cyclones. The ability to track and predict tropical cyclones has come a long way since the days of relying solely on ship reports and coastal observations. Today, we have a sophisticated array of tools at our disposal. Satellites play a crucial role in cyclone tracking. They provide real-time images of storms, allowing meteorologists to monitor their development and movement. Weather buoys and aircraft reconnaissance missions also provide valuable data. These tools measure wind speeds, air pressure, and other crucial parameters. This information helps meteorologists understand the storm's intensity and structure. Computer models are another essential tool in cyclone prediction. These models use complex mathematical equations to simulate the behavior of the atmosphere. By running multiple models and comparing their results, meteorologists can generate more accurate forecasts. Despite these advances, predicting the exact path and intensity of a cyclone remains challenging. Section 9. Historical cyclones. Lessons from the past. Throughout history, tropical cyclones have left an indelible mark on human civilization. Some of these storms have become infamous for their destructive power. The Great Bola Cyclone of 1970, for instance, struck East Pakistan, now Bangladesh, with devastating force. It claimed an estimated 300,000 to 500,000 lives, making it the deadliest tropical cyclone on record. In the United States, Hurricane Katrina in 2005 became a defining moment in the nation's history. The storm caused over $125 billion in damage and claimed more than 1,800 lives. It exposed vulnerabilities in disaster preparedness and response, leading to significant changes in emergency management practices. These historical cyclones have taught us valuable lessons. By studying these past events, we can better prepare for future storms and minimize their impact on human lives and livelihoods. Section 10. Living with cyclones, adaptation and resilience. For communities in cyclone-prone regions, living with the threat of these storms is a fact of life. Over time, many of these communities have developed remarkable adaptations and resilience strategies. In Bangladesh, for example, the government has invested heavily in early warning systems and cyclone shelters. These measures have significantly reduced the death toll from cyclones in recent years. In the United States, building codes in coastal areas have been strengthened to withstand high winds and storm surge. Many homes in hurricane-prone areas are now built on stilts to elevate them above potential flood levels. Nature-based solutions are also gaining popularity. Mangrove restoration projects, for instance, can provide natural barriers against storm surge. Education and community preparedness are crucial aspects of resilience. While we can't prevent tropical cyclones from occurring, these adaptation strategies help communities better withstand their impacts and recover more quickly in their aftermath. Section 11. The future of tropical cyclones in a changing world. How will tropical cyclones change in a warming world? Climate models suggest more intense storms. Warmer oceans provide more energy for storms. Cyclones may form in new regions. Cyclones might slow down, increasing rainfall. Sea level rise will make storm surges more destructive. Continued research and improved forecasting are crucial. Our actions today will influence future cyclones.